Hello everyone, welcome to my YouTube channel. So today we are going to discuss about the third topic, that is frontier of future and overview. So here usually when we are speaking about the future of nanotechnology, we would like to mention any such applications which are not happening at bulk. Anything you mention is fine for here. And you can mention few applications in the end. You try to take out some examples and mention it and try to give some applications of nanotechnology, and that should be sufficient for this topic. Okay, so according to your syllabus and whatever the textbooks have been mentioned in your syllabus, based on that these are the topics, these are the points which I am going to discuss. So the deviation from the bulk phase, when you start from when you see the things at bulk phase, okay, that we have already discussed in previous classes, and to the nanoscale, there is a huge difference, okay, in terms of properties, in terms of many other things. So there is a huge difference. That difference makes the nanotechnology is so cool, so that we have discussed in previous classes. So here we'll directly moving to this thing. For example, when there is some particular property what you are expecting from a material, say for example as alloys or something like that, so you are not getting that property at bulks. In order to go for further, you need to understand what is the difference between bulk and nano. Bulk is something what we are already using now without the help of nanotechnology. Okay, so any material you are just directly using as a raw material or something like that, that will become as just a bulk material. And we are talking about the nanomaterials, the same bulk materials, you are going to crush it, grind it and make a powder where every single particles in that particular powder has to be in nanoscale or less than the 200 nanometer, and then the same powder or same raw material you are going to use to make alloys or materials, metals or ceramics, whatever it is. So that will become as a nanomaterial based product, or you can say that is a material which is synthesized by the nanomaterials. So that will have all the properties what you are looking for and which is not there in the bulk materials, understanding. So for example, imagine I am using a normal bricks to construct my home. So as a bulk materials, we are taking cement, that, this and all, and we are putting it all normally. Whatever we are doing, it's a macro particles we are using. So now what I will do, the same cement what I use, whatever the things I use to build this particular brick, now I reduce that cement to the nanoparticle size, where single particle should be in macro scale, it has to be in nanoscale. And once I told to go to the nanoscale, now I am going to prepare this particular brick. So I have a brick A which is just prepared as it is. I have a brick B which is prepared by the nanoparticles now. So brick A you can call it as a bulk material, whereas brick B is called as a nano brick. Why nano brick? Because it is prepared by the nanoparticles. Okay, and whereas brick A is prepared by the macro particles, or maybe the more than that. Okay, or just raw materials which is more than micron size also. Okay, so there is a difference. So here if you compare both A and B, A will be having, imagine the hardness of around something, so B will be having around 2 to 10 or sometimes even 15 times better hardness than the bulk, brick A. So that's what the nanotechnology is doing here. That's how the nanotechnology is making its way in the field of every field, here in the field of construction, or in the field of civil engineering, or in the field of mechanical engineering, or in the field of biology, or in the field of any kind of stuff you are talking about. If it is about environmental, if you are, which is about your batteries, where instead of using normal cathode and anodic materials, you use the carbon nano particles, coat on the anode and cathode materials, and then use it. You will get the better quality of your electric conduction, in terms of electric conduction, in terms of oxidation, instead of production, instead of durability, in terms of efficiency, all these properties will be improved. So that's what all these things you can improve. You can include all these points also in your frontier of future and overview, but we have to go with your syllabus or according to your textbooks. That's why these points are. So those who really want to make these notes, whatever I just explained, if you write these also, you should be getting the marks for the frontier of future and overview of the nanotechnology. So let's get started. So the deviations from the bulk phase diagram may be exploited to form a certain composition of alloys. So you are going to expect, or you are going to exploit some particular certain compositions of alloys, or otherwise unstable in the bulk form. So imagine they are in the bulk, you want certain property, for that certain composition of alloys are required, but that is unstable in the bulk form. So during this time, you can reduce this all the composition to the nanoscale and make that alloy, and that should be giving the properties what you are looking for in the alloys. So in addition, why we should be getting, why I am telling with so much confidence, because the nanomaterials will give you more ways, or you can manipulate as the size, as you go on manipulating the size, the properties are getting changed. We have seen it in the earlier classes, right? We discussed about the gold changing its melting point. We discussed about again not only its melting point but also its colors, right? From gold to the yellow to the purple to the red color, right? So similarly, the mechanical properties also change, right? Electronic properties also change. So whatever the properties I need, the particular alloys, okay, with the particular composition, if I am not getting in the bulk form, then I am going to use the nanotechnology, and with the help of nanotechnology I am going to get that property. Unless and until I get that property, I will not stop. I will keep on using it. I will keep on changing the data. I will keep on changing the composition. Okay, or by doing so I can have this particular property which I am looking for. So that's the beauty of nanotechnology. So in addition, the thermal stability of the interfacial regions is typically less than that of the bulk material. So what happens, why this instability is there? Because the thermal stability of the interface regions, that means in every particles or every compositions in the alloys, in there the interfacial regions are there, that thermal stability is typically less than that of the bulk material. So thus the nanophase material are often sintered or used or utilized or exploited or undergo the phase transformation at different temperatures. As we seen in the gold, how it changes its optical properties and also we have seen at the different temperature, different nanoscales, we are having the different temperatures, right? Different melting point. We are right. Those are the proof that the nanotechnology, nanomaterials at different scales might get whatever the properties I want. So if I will check for 30 nanometer, if I am not getting, I will go for 50 nanometer, if I am not getting, I will go for 70 nanometer. One or other way, you should be getting whatever the properties you are looking for from the particular composition of the alloys. Okay. So this is a characteristic which has a numerous application to material processing. That is the best characteristic which we are getting from the nanotechnology. So that will be having a lot of application in material science. So by improving the materials properties, we are able to find applications such as, for example, we can have varied as semiconductor electronics. Okay, we can vary at different sizes. We can get the different band gap. With different band gap, we can have the different semiconductor properties. Okay, and then the sensors, and then the special polymers, magnetics, and advanced ceramics, and as well as membranes. In all these way, the material science. Okay, we can have whatever the properties we want, whatever the characteristics we want with the help of nanotechnology, because the manipulation is the key. You have to remember the word manipulation, and manipulation of the properties can be done easily at nanoscale. So we need to improve our current understanding of the particle size control, because at different size what properties I am getting. So that's why we need to understand our current understanding, that means the current knowledge about the particle size and the different methodologies or approaches which are used for several classes of the nanophase materials, and also address the issues of the particular characterization. So once you address this, once you get to know what nanomaterials giving me the what property, then you can definitely solve whatever the properties or whatever the properties you want at bulk, that you can get it easily. So we should also explore the fields in which there are foreseeable applications are there of nanophase materials to long-standing materials problems. Whatever the materials problems are there, that we need to get the solution from the nanotechnology by changing the nanophase and all, right? Since these issues have to be tackled by us. So as I said earlier, there is a scope of wider applications in the field of in the fields with the help of nanotechnology. Maybe it is I'm mentioning few here: electronics in terms of the thin films, of maybe it can be the graphene nanosheets, or it can be the carbon nanosheets, or it can be the nanoparticles, whichever you are using, and you are going to prepare the silicon layers for your electronics industry, or maybe for your FETs, MOSFETs, okay, JFET, and as well as electrical ceramics. So then those are the applications. So whereas next we are having the bionics, photonics, bioceramics, and we are having the biotechnology and medical instrumentation. And these are all the major part of the applications where the material science is involved, and we can have the whatever the characteristics or the properties what we are looking for from from the bulk. If I am not getting it from bulk with the same materials, I am going to reduce it to the nanoscale, and I will be definitely going to get those particular properties. So nanotechnology applications, you can see many of a number of applications are there in terms of nanomedicines, nano-biosensors like biochip and all, nanofluidics like VLOC, biofluidic devices. Next we are having the molecular self-assembly. Here LOC is nothing but liquid organic crystals. Next we are having molecular self-assembly, okay, and then intelligent drug delivery systems and nanomedicines and other nano-bio devices, okay, and systems. So nano drug delivery systems are nothing but you are going to use for particular nanoparticles in order to deliver the drug inside the particular tumor or particular space or particular place at a location of our body. Next, nanomachines are there. Nanomachines will be nothing but which will have the impact in both in biomedical field and even in material science. So other bio devices applications and systems also can be made available. So one of the example I would like to explain is nanomachines. So here with the help of nanomachines are nothing but what any parts of the machine, if they are made up of the at nanoscale or nanotechnology, we can call it as nanomachines. So designing of a molecule for forming you are going to design a particular molecule. Obviously when you are talking about molecules, that has to be made up of nanoscales, right? So design of these particular molecules performing mechanical function is one of the largest goals of the nanoscience. That means, see, we all are made up of what? Molecules, and every materials is made up of what? Again, atoms and molecules. That's why if you are able to create a nanomachines, then you are able to play with molecules and atoms, and when you are able to play with atoms and molecules, you can bring any properties whatever you want. Okay, that's the beauty of nanotechnology. So development of such molecular systems would lead to the creation of the integrated nano devices. So several molecular systems will be there that have been designed to perform translations and as well as rotations. Translations and rotation in terms of which are already being prepared molecular systems. The molecular systems only you can call it as nanomachines because it contains nanoparts. So also being used as switches and logic gates also. So why nanoscale has become so important, this we have discussed in earlier class also. The same points here also you can mention. 4 major properties makes nanotechnology or nanomaterials so special, because first thing is quantum mechanical properties of electrons. Obviously when it is about the lesser than the atomic and molecular scale or at atomic scale, the bulk physics whatever we are studying, classical physics, it doesn't work. We have to go for the quantum mechanics, and since the nanomaterials also exist less than almost near to the atomic size, they also exhibit quantum mechanical effects, and these effects will be helpful for our to vary or to have the particular materials with the possibility of varying micro to the macroscopic structures, such as for example I can vary charge capacity whatever I want. The magnetization I can vary, melting point I can vary. so without changing their chemical composition. That's the beauty of the first property, that is quantum mechanical property, we discussed in the previous classes. Then next we are having biological entities. If you are joining with the material science, you will get a number of applications. You can create a lot of things. You can put in man-made things inside human body with the biocompatibility, biodegradability, all of the applications. And third, we are having very high surface to volume ratio. More the surface, obviously more applications. You can go back and see my video for a detailed explanation. And next, macroscopic systems, which are made up of nanostructures, will have more higher density than that of the made up of microstructure. If in the beginning of this class, I had given example of brick A and brick B. The same thing, brick A is made up of macrostructure, brick B is made up of nanostructure. So nanostructures, which is brick B, will be having almost all the properties in this. It will be better compared to the other thing. So all those things will come into picture as one of the, the attributes for the frontier of the future, which puts in conclusion that the nanotechnology is going to make a lot of differences in our future. So that's it. Next topic, we are having length scales, that we will discuss in the next class.